My name is Anne-Marie Fjero. I'm responsible for the training program of data submission to EVDC, the ESA Atmospheric Validation Data Center. In this training video, which is the first of a series of 3 videos, I'll show you how to format your CalVal data for the EOS mission. This is the front page of EVDC located at evdc.esa.int. On the top of the page, there are categories for the tools and functionalities of EVDC. In the upper right corner, there is a login button. For best performance of the system, we recommend that you log into EVDC with your personal user account. If you do not have an account yet, please find under Contact Us the link to the EVDC data protocol. The protocol can be read and signed digitally. Once you have received your user credentials, you can log into the system and find your personal workspace under My EVDC. The functionalities of the personal workspace is presented in another video. This video only takes into consideration the data formatting templates that are found under Tools. GEOMS stands for the Generic Earth Observation Metadata Standard. We have a long list of data formatting templates in EVDC. There is one for each instrument type. Each template is built on a syntax with metadata attributes that describes the data, the instrument, or the PI. We will go through this a bit later. At the bottom of the page, we have printed a few examples where we have the metadata and the data part. We will now briefly show you how the metadata part is built up. We will use the balloon measurements as an example. The metadata will be the header of our file. A metadata header file has 2 parts. It has some global attributes on the top, which describes something about the PI, the measurement principle, the station where it's located, and also in case if you have a DOI, there are placeholders for that in EVDC. There is data variables, for example, date time, latitude, longitude, altitude, and what you measure. They will be reflected in the local variable attributes further below in the header. There is no restriction on how many local variables you will add into a file, as long as you just list them in the global variables in the top of the file. We will now go back and see how the data part of the file is built. It's listed here. In the data part of the file, you will recognize the variables that we earlier saw in the metadata header. For example, you would have date time, latitude, longitude, altitude, and so on. The data file is listed in one single column with all the matrices listed after each other. In the next video, we will show you how to use the GEOMS tool. The GEOMS tool is an online tool to create HDF4, 5 or NetCDF files out of the examples files from the metadata header and the data part that we just learned about.